Good day, everyone. I'm here to talk about solar energy. Just as in my last video, where I talked about solar energy as one of the sources of renewable energy, which is most being harnessed this time, and I would say affordable both for residential, commercial, and industrial use. In a small and basic term, is the light and heat energy we receive from the sun. And we know that the sun will continue to be as the earth exists. And the sun, being the center of our solar system, is the energy supply for our planet. And you know that when we talk about the solar system, we are not here to talk about solar system, but at least when we talk about the solar system, the solar system consists of the star, the sun, and everything that is bound to it, at least the Mercury, the Venus, the Earth, the Mars, the Jupiter, and all of that. But the solar system is the center. I mean, the sun is the center of our solar system. And we know that we have radiations and different types of solar radiations we have, just like the radiations can be diffuse, reflected, and direct. We are not here to talk about that, but the solar radiation is a driver for many chemical, biological, and physical phenomena in the atmosphere. And we know that the plant, even itself, cannot do anything without the solar energy. That is, when we talk about photosynthesis, how plants manufacture their food. So solar energy is very important, and this type of energy is renewable and inexhaustible. That is, it cannot go to extent daily. Even if we don't have the peak sunshine, we still have some light, that form of light. So it is renewable and we cannot exhaust it. How solar energy works: solar panels are made up of photovoltaic, that is, we call them PV cells, PV for short. We still go to that when I begin to deal with the uh, components of solar energy, that is, components of solar energy system. If you want to do it for your residence, for residential purpose, for commercial purpose, there are some basic components that we'll still discuss. And photovoltaic cells, we have the forms of photovoltaic cells too. That is how they are made, the types. Yeah, the crystalline structure, we have the mono, the poly, the amorphous, the thin film, and the like. So we still discuss that later on. So solar panels are made up of photovoltaic PV cells that convert sunlight into direct current electricity, that is the DC, throughout the day as long as the sun shines. So PV cells, we have something we call photovoltaic cells, and this photovoltaic is I think a Greek word. The photo means light and the voltage means electricity, that is the voltage. So it's a combination of two things, that is the photo that means light and the voltaic that means voltage, which is talking about the electricity. So it's these cells that convert the sunlight, the rays we receive from the sun, into direct current electricity. Though there are still some methods and processes involved. We have something we call the photovoltaic effect. We'll discuss that in details later on. So throughout the day, as long as the sun shines, as long as the sun shines, then the solar cell will continue to generate electricity. So they are in three or four forms. We have the solar cell, we have the solar module, and we have the solar panel, then we have the solar array. This is a typical cell. That's a cell. Solar, and it has its own parameters, like each cell has a current rating, they have a power rating, then they have a voltage. And these cells are the ones that are formed into module. And this module is just like a single panel. So it's either they are connected in series and parallel. We still consider that later on in one of the videos I will still do for you to learn more. So you can see a solar cell is a single entity. Then the combination of solar cells makes a solar module. Are you getting it? And they are connected in series and in parallel. Then the combination of solar module makes a solar panel. So if you have one solar module, combined with another solar module, you have a solar panel. Then combination of solar panels together, maybe you would have seen some installations that will require maybe 20 solar modules. You understand, they are formed into arrays, and all these have some basic parameters. The more the solar panels connected together, the more the powers, the more the voltage, the more the current, and all these are arranged based on uh, what your requirement is, at least, I mean, what you want to achieve, whether you want to connect your solar panels in series, whether you want to connect them in parallel. It depends on what you want to achieve. Then I'm talking about the inverter. This is one of the components. Just want to talk on it. The inverter means when you invert something. I made mention of uh, that the photovoltaic cells converts the sunlight into direct current electricity. So it's the inverter that converts the direct current electricity, that is the DC electricity generated by the photovoltaic cell, into alternating current that most of our appliances use at home. So this is the device that converts the direct current electricity generated by the solar panels into the alternating current AC electricity. The AC electricity from the inverter output is connected to your electrical power panel to power your lights and appliances with solar panel. Just that in many homes, we use alternating current. It depends on the region, the country where you reside. Mostly in my country, we use 230-volt AC. You understand? Some countries use between 120, 100 to 120-volt AC. So it depends on the region you are. That one will depend on the types of inverter you will use. But the basic thing is that the inverter cord convert direct current generated by the solar module or the photovoltaic cells into electricity, that is alternating current, that we use to power our appliances at home. Not that some people don't. Some people use DC components at home, that is DC bulb, DC television, DC fan, but it's not that common. It's the alternating current appliances that are most commonly used at homes and in the residential places, industrial places, commercial places. This is also solar energy. You know that the basic things, why the basic and important thing we use solar energy for, is to provide our homes, hospitals, clubs, churches, commercial centers, banks, and the rest, to provide them with electricity. That is, to provide lights, to power our systems, to power our TVs, to power our machines, and the likes. And it's a form of heating too. We know that solar energy, we use it to provide form of heating for heating. Yeah, even if you power your electric kettle, it's a form of heating through electricity. Some even use them to power their system. Maybe, for instance, generating stations, they use solar energy to boil water, or maybe for turbine. Then ventilations, like to power our air conditioning system, to power our high high voltage systems. And then for drying, we know, even if for direct drying outside, you use solar energy for direct drying. Then we can use it to power our ovens for drying our consumables at home and in the offices. Then for gardening, so solar energy too is used for gardening, maybe to water our vegetables, to water our vegetations, maybe even in the farm for irrigation purposes. So solar energy, we have water pumps that uses solar energy directly, even direct current, depending on the voltage. Then for cooking, yeah, we can rule out that we have some means of clean cooking. Yeah, that we use solar energy, so that it doesn't generate maybe any carbon monoxide or carbon You understand everything that contribute to climate change. We use solar energy for cooking. And for security, maybe to power our CCTV, are you getting it? So these are just the basic things. Solar energy uses are numerous. We cannot overemphasize the use. And for home beautification, yeah, it's very for home beautification, maybe for lighting, different types of lighting can use solar energy. Solar energy technologies. We have so many technologies that we can talk about. Yeah, they are very numerous. We have so many energy technologies, solar energy technologies, but I will just mention basic ones to add means to the usage of solar energy. Photovoltaics is the process of converting light photons to electricity voltage, as I have mentioned before. And this is also known as the photovoltaic effect. So this is a PV plant. You can see this is a PV plant. At least you can see how they are arranged. And I told you that it can either be arranged in series or in parallel, depending on the output we want and depending on what we want to use it for. Then part of the technology is what we call concentrated solar panel. And this is the use of mirrors or solar panels to reflect and concentrate. That is, you arrange them. Some may be in parabolic form, some may be in rectangular form, and it will be just be focused towards a particular thing. It may be for the purpose of heating, for the purpose of boiling water, maybe for industry, for the purpose of maybe we have a generating station that uses a steam turbine produce electricity and you needed to boil water instead of using the furnace. So this is one of the uh, technologies that is solar energy technologies use. And as I've explained, said this is the use of mirrors or solar panels to reflect and concentrate the sunlight to a receiver. That it is that receiver that we now be connected to a boiler maybe for the purpose of heating. And as you can see in the three pictures, you can see the first one is concentrated. It's arranged maybe in a circular form. And you can see them so that when the sunlight receives, there will be a receiver, and through that receiver, it will be sent to maybe the boiler that contains the water, and it is that heat that will be used to boil the water to generate maybe the steam that we want. And solar thermal energy. This is the energy created by converting solar energy into heat. This is another form of technology, and these applications are not limited to, they are used for space heating, for cooling, for water heating, both for commercial and industrial use. So this is another form of thermal. When we say thermal, you know that we are talking about heat. So it's used for heating, for cooling. And then we have another one that is the passive solar energy. This is the use of natural light and heat from the sun to warm up a building without incorporating any mechanical system. When we say we are not incorporating any mechanical system, that is, there's no form of maybe conversion, no electrical system, so it's just in its natural self. So this is achieved by the use of large windows to absorb and store energy during the day, the use of shading to reduce unwanted heat during daytime is employed too. That is, for maybe when you are in your house, then the sun is becoming too much, you just bring down your window blind to cover the sun so that at least the room will be cooled. You can say those are passive, that is not active, no form of conversion system takes place. And when we say, just as is mentioned, that is windows, walls, floors are made to collect or store energy, to reflect it, or to distribute solar energy in the form of heat. For example, you can make use of thick walls or insulated walls. Do you understand? Just to ensure cooling. You know, when you make use of thick walls in your house, there's no mechanical conversion that takes place. I get it. So those are passive. Then building integrated photovoltaics. You understand? This is the integration of PV panels into buildings for the purpose of generating electricity for such buildings. And this reduces or totally eradicate the dependency on traditional power supplies. This increases the energy efficiency and sustainability of such building. How do we mean? The BIPV for short, that is the integration of PV panels. Instead of maybe you have a commercial building. For example, there is one commercial bank, I won't mention it, in my country now, that they are solely dependent on renewable energy. All the windows are made up of PV cells. Do you understand? So all these PV cells are just arranged. Instead of using the conventional windows, they make use of solar panels all through just to power their system. So there's no form of maybe burning fossil fuel like diesel, like petrol. No. And this reduce total eradicate the dependency on they not depend on maybe public power supply to power their building, to power their air conditioning, to power their computing system. So it increases energy efficiency, and they will know how to conserve the energy. There's no wastage in energy. You understand? So just as these pictures, these are basic. All these ones you would think maybe they are windows. No, they are solar panels, and they are self-sufficient. So these are some of the basic technologies that are being employed by solar energy. You can still search more about them. Thank you. Please like, comment for further research. Your comments will be very important for me so that I'll be able to do more. Then click on the bell button for more informations, and subscribe for more tips on do-it-yourself projects, renewable energy technologies. Thank you.